Assalamualaikum and good day to the panels and the audience. Today I will be presenting on my final year project proposal entitled The Analysis of Fluid Generative Design for Valve in Metal Additive Manufacturing. The researcher is myself, Muhammad Syazwan Bin Ahmad Khadhri, and I am from the Faculty Mechanical Engineering. And my supervisor is Prof. IRTS, Dr. Engineer Yupita Harangan Prasada Manurung. For the project summary, the study will focus on valve design for the optimized fluid path with lowest pressure drop. The second, perform a fluid generative design on a valve. And the third, run fluid flow analysis and run the 3D printing simulation in order to check the manufacturability of new generated design. The software that we use Autodesk Fusion 360 and Autodesk CFD 2023. And this study is to generate design with optimized performance on pressure drop. For the introduction, the process of fluid generative design is a method for designing systems that explores several optimal design choices for fluid flow. Fluid generative design is a useful tool for exploring design concepts that may be impossible to build using traditional manufacturing methods. So here, additive manufacturing were introduced as a solution to manufacture parts with complex cross-sectional areas. Next, pressure drop. Pressure drop is a phenomenon that may occur in process pipe systems. Basically, pressure drop is a difference in total pressure between 2 points of fluid carrying network and caused by a friction between fluid and the wall of device that will lead to a loss system performance and increased energy usage. A well-designed valve can help to reduce pressure drop. Next is literature review. First, additive manufacturing, also known as a 3D printing, manufacturing process is created by adding layer by layer of material. Also utilize a computer-aided design CAD file that converted to a stereolithography STL file. Next is metal additive manufacturing, MAM, provides wide capability to produce geometrically complicated metallic structures with design flexibility and optimal performance. Next includes direct energy deposition (DED), power back fusion (PBF), and binder jetting and sheet lamination technique. And the next is selective laser melting (SLM), fast prototyping, 3D printing, or additive manufacturing technology designed to melt and fuse metallic powders using high power density laser. Okay, next continue with generative design, GD, the process of using algorithms to generate design options based on specific design goals and constraints, also used to create unique, efficient, and innovative designs. And lastly is fluid generative design, FGD, the process that involves the use of computer algorithm to generate design option based on the flow of fluids such as air or water through a system. Also used to optimize the design of systems such as air ducts, piping systems, and heat exchanger for maximum efficiency and performance. So the current valve design has pressure loss in it, and conventional manufacturing method has limited on design degree of freedom. Therefore, the objectives of this research are to design valve using fluid generative design to simulate 3D printing process and to analyze and compare results obtained between theoretical and experimental. The study will focus on valve design using Autodesk Fusion 360 and Autodesk CFD 2023 to perform a fluid generative design, to run fluid flow analysis, and to perform a sculpting process. Perform a 3D printing simulation for SLM manufacturing process on Autodesk Fusion. Fluid generating design will be run with objective to minimize pressure drop and performance to be measured pressure drop, maximum pressure, and maximum velocity. Like every research work, limitation to this study is the difficulty to quantify all variables may affect the behavior of the product in real-life situations. Thermal stress neglected in this research. For methodology, first study on cases that related to current research, then identify the problems and objectives. Next, model preparation using Autodesk Fusion 360 and run the fluid path tab for generate new design. Once get the outcomes, the 3D model will be exported to Autodesk CFD 2023 to run fluid flow analysis. Then sculpting on organic model will be performed at the critical zones. After done the sculpting process, again run the model into fluid flow analysis. After gain the result will be compared before and after sculpting process. Next, perform 3D printing simulation and printing prototype using fuse deposition modeling (FDM) and conduct the experiment. Next, theoretical and experimental result to be validated. And the next, discussion and conclusion. And the lastly, end for the research. Move to the next slide. Expected result. First, a fluid generative design. Perform FGD and analysis on Autodesk Fusion 360. Next, organic sculpting. Improvised sculpting method to smoothen critical zones. And the next, fluid flow analysis. Generated design expected to have lowest pressure drop. And the next, comparison, a result obtained from original design, generated design, and organic. After sculpting will be compared. And next, 3D printing simulation. 3D printing simulation will be run on Autodesk Fusion and Cura. Move to the next slide. Here is my preliminary result that I obtained from this research. The comparison between original design, optimized design, and organic design after sculpting process, with performance that be measured between maximum velocity, maximum pressure, and pressure drop. And this slide is my project planning for FYP1 and FYP2. So here the list for project activities. First, FYP title and supervisor search. Project title registration, research background, literature review, software installation, problem statement and objective, methodology, preliminary result, proposal preparation, proposal submission, proposal presentation, technical report, thesis, and lastly a final presentation. So here the expected and the work has been done by me. That's all from me, and thank you for listening. If you have any concerns or questions, please reach me through my email or my contact number above, and thank you.